Hi everyone. Today we're doing notes for 3.3, truth tables for negation, conjunction, and disjunction. So first, we're going to do the truth table for a negation. So if our statement P is true, the negation of P is going to be false. And if our statement P is false, the negation of P will be true. When you break a compound statement into two simple statements, these are called component statements. So again, when you break a compound statement into two simple statements, these are called component statements. Next, we're going to talk about the conjunction. So a conjunction, this is for the word and, is only true if both component statements are true. So here's what our truth table looks like. For P, we have true, true, false, false. For Q, we have true, false, true, false. If I'm combining these with and or using the conjunction, if I have true and true, that gives us true. If I have true and false, that gives us false. False and true is false, and false and false is false. So again, the conjunction or and is only true if both component statements are true. Next is the truth table for disjunction. So a disjunction, which is or, is only false if both component statements are false. So if I have true or true, that's true. If I have true or false, that's true. If I have false or true, that's true. And if I have false or false, this one's false. So again, a disjunction or is only false if both component statements are false. So here we have two statements. We have that P is 3 plus 5 is 8, and we have that Q is 2 times 7 is 20. So we know the first statement, 3 plus 5 equals 8. That is a true statement. Our statement Q, 2 times 7 is 20. That is a false statement. So we have to determine the truth value for each statement here. So let's do A and B together. A, we have P and Q. So if I have true and false, that's going to give me a truth value of false. If I do B, I have P and not Q. So that is true and not Q would be not false, which is true. And so then true and true would give me a truth value of true. Now I want you to take a minute and please figure out the truth value for C and D. Okay, so for C, we have not P or Q. So not P, so not true would be false, or Q is false. If I have false or false, that gives me a truth value of false. For D, we have not P or not Q. So not P, not true, is false, or not Q, not false, is true. False or true gives us true. Okay, for this next one, we're going to construct some larger truth tables. So let's do two together. We have to construct a truth table for the negation of P or Q. Or we could say it's not true that P or Q. So first, we're going to do what's inside the parentheses. You can kind of think about constructing truth tables like doing order of operations. You start inside the parentheses and you work your way out. So first, let's do P or Q. So true or true is true. True or false is true. False or true is true. False or false is false. Now we're going to do the negation of P or Q. So now I'm just doing the negation of what we just did. So the negation of true is false. Negation of true is false, same thing. And the negation of false is true. Okay, let's do this next one. So here you need to construct the truth table for the negation of P and the negation of Q. So this is your first time doing one of these. I'm going to have you do this one on your own, but I'm going to help you with what you need to do across the top. So for each of these, we need to find the negation and then put them together with and. So first, I want you to find the negation of P. Then I'm going to have you find the negation of Q. Once we have the negation of both, then we're going to find the negation of P and the negation of Q. So take a few minutes and I want you to fill in this truth table. Okay, so the negation of P, we see P goes true, true, false, false. So the negation is going to be false, false, true, true. The negation of Q, we see Q goes true, false, true, false. So the negation of Q will be false, true, false, true. So now we're going to take these two and put them together with and. So we have false and false is false. False and true is false. True and false is false. And true and true is true. Okay, let's do the next one. Here we have to construct a truth table for P and not Q or not P. So we have several different things here. So let's start by first doing the negation of P, the negation of Q. So negation of P is going to give us false, false, true, true. The negation of Q is going to be false, true, false, true. Okay, so now the next quantity we have is what is in the parentheses. So we have inside the parentheses P and not Q. Okay, so we have P and not Q. So for this one, we're combining this one, P and not Q. Okay, so let's use these two. And again, we're combining these with and then we're going to put the answer right here. So P and not Q. True and false gives us false. True and true gives us true. False and false gives us false. False and true gives us false. I'm going to switch colors so you can see this a little bit easier. For the next one, we're actually going to put everything together. So we're going to do our P and not Q that we just did, or not P with that. So again, we're doing this one that we just did, P and not Q, and we're oring that, or doing the disjunction with not P. So now we're combining these two with or. And we're going to put that here. Okay, so we have false or false, which is false. False or true, which is true. True or false, which is true. And true or false, which is true. Sometimes I think it helps to use different colors, different markings. You can circle the different columns, whatever makes it easier for you to understand these. Okay, so for this next one, we're going to construct a truth table for P and the negation of P. So if we have P is true and false, and then we have the negation of P will be false and true. I'm going to give you a few minutes. I want you to find first this one, P and not P. And then I also want you to find the truth table for P or not P. So please take a minute and fill those in. Okay, so for P and not P, I have true and false, which is false. I have false and true, which is false. So here, we have two falses, and we have a special name for this. A compound statement that is always false is called a self-contradiction. Okay, a compound statement that is always false is called a self-contradiction. Next, we have to do P or not P. And for this one, if you have true or false, that's true. If you have false or true, that's true. And so anytime you have a compound statement that is always true, this also has a special name, and this is called a tautology. Okay, so again, compound statement that's always true is called a tautology. Okay, here's our next one. Now we're going to get to a truth table where we have 3 compound statements. So here you can see we have P is I study hard, Q is I ace the final, R is I fail the course. So you have to construct a truth table for I study hard and I ace the final or fail the course. So in order to do the truth table, the first thing we have to do is write this statement symbolically. So we have to pay attention to a couple of important things. We have to look for important keywords and look for commas to help us with placing our correct symbols. So we have I study hard, so that's P. Then we have a comma, and so that comma, what this is doing is it's basically splitting our sentence. We have I study hard, and then we have and. Then this whole rest of the sentence is going to go in parentheses because that's the second part of our statement. So then in parentheses, I have I ace the final, Q, or I fail the course. So we have P and then in parentheses, Q or R. Okay, so we know from doing our previous tables that we have to do what's in parentheses first. So let's do Q or R first. All right, so I'm going to give you a minute, and I want you to fill in Q or R in your truth table. Okay, so Q or R. If we have true or true, that's true. True or false is true. False or true is true. False or false, this one's false. True or true is true. True or false is true. False or true is true. False or false is false. Okay, next, and I'm going to switch colors again to make this easier for us. Now we're going to do the whole statement. We have P and Q or R. So we're doing P, which is this first column, and our Q or R, the column we just did. So we're putting these two together, and we're going to list them right here. So now we have true and true, which is true. True and true is true. Whoops. That's weird. True. True and true is true. True and false, that gives us false. False and true is false. Then we have false and true, which is false. False and true, which is false. And false and false, which is false. Okay. So now it says, suppose that you do not study hard, you ace the final, and you fail the course. Under these conditions, is the compound statement in part A true or false? So let's think about this. We have statement P, statement Q, and statement R. So when we're looking at these statements, P is I study hard. But this says you do not study hard. So that means that P is false. It says you ace the final. So ace the final, that means Q is true. And you fail the course. That means that R is true. So we're looking for FTT in our table. And so that is this one right here, this row. And so if we look here, we have that our compound statement is false. Now there is another way you can do this if you want. You can also simply just plug in the values into our original compound statement that we have. So remember, we had P and Q or R. So I can plug in our values, false and true or true. So then if I do what's in parentheses first, true or true is true. False and true is going to give me false. And so you see, we get the same result either way. Okay. Last, we're going to determine the truth value of a compound statement for a specific case, which is kind of like we just did with our another way. Okay, so here we have a picture, and it says the bar graph in figure 3.2 shows the distribution of looks for American men and women, ranging from homely to strikingly attractive. So it says 2% of American women are homely, or more than half are good looking, and it is not true that 5% of American men are strikingly attractive. So we have lots of things going on in this compound statement, and we have to determine the truth value here, okay? So first, we're going to look at the different components. So first it says 2% of American women are homely. Okay, so let's write this. We have 2% of American women are homely. And if we look at the chart, by homely, we see women is yellow, and so homely women 2%. So that is true. The next part of our statement says more than half are good looking. So we're still talking about American women here. So I'm going to say more than half of American women are good looking. To make it a full statement there, because we're still talking about the American women. All right, so now if I look at the good looking part, looking at women again, this says 31%. So that is not more than half. So this statement is false. The end part of our compound statement here is it is not true that 5% of American men are strikingly attractive. So we're going to be stating just this statement. We're not going to be putting the negation in there. So I'm going to put 5% of American men are strikingly attractive. And if I go to strikingly attractive and I look at American men, so now we're looking at the orange, that's this one, and it says 2%, not 5%. So this one is also false. Okay, so now it says we need to write the compound statement symbolically. So we defined what P, Q, and R are. And now we're going to take this big compound statement and we're going to write it symbolically. Okay, so if you pay attention, we have the comma is located here. So that's where we're splitting our sentence. So we know the comma is by the and here. So I'm going to have an and. The first part of the sentence says 2% of American women are homely, or more than half are good looking. So that's really just taking P or Q. After the and, it says it is not true that 5% of American men are strikingly attractive. So that's the negation of R. So now we have to substitute in our truth values for P, Q, and R that we just determined. Plug them in and find the truth value. I want you to take a minute to plug in your truth values for P, Q, and R and find the truth value of the compound statement. Okay, so if we plug this in, we have that P is true, or we have Q is false, and we have the negation of R, which is false. So let's simplify. Inside our parentheses, true or false is true, and the negation of false is true. And so if we have true and true, that is true. And so the truth value of our compound statement is true. And that's the end of our 3.3 notes.